Welcome friends, welcome you all in my channel Chemistry, the Mystery of Molecules. I am Tanmoy. Today we will discuss a question for practice. This question. So actually I didn't take this question from any previous NET or GATE, I guess. So if you found that this question came in any previous year NET or GATE exam, please mention it in comment. So let's start the question. This question may come for 2 marks question, such type of question. So the question is, arrange the hydrides according to their stability in water. One sodium borohydride, one sodium cyanoborohydride, one is lithium borohydride, and one is trimethoxy borohydride. Okay? So you can see the question in the screen for if you can't see in the board. So I request you, please pause the video and try to solve the answer by yourself, and definitely I'll explain and give you the right answer at the end of this question. For any query or such, in case of such questions made by me, for any query confusion, please mention in the comment, and if you found any answer is not right, then please mention it. So let's start. So you can see, what is the question? Question is hydrides water stability. Okay, this is A, B, C, D. Now such type of question you have to first at a glance you have to find out what is more stable, what is less stable. For example, this is less stable. We know sodium borohydride, lithium borohydride is very reactive compared to sodium borohydride. And I suggest you, I made a video previously about according to this hydrides. I will give the link in the first comment. So please have a look. This is sodium borohydride, lithium borohydride, least stable. Sodium borohydride after that. Now the question is about this. Okay. Which one is reactive more? Now, I'll give some logic. First one, this is unstable. So, we got it. So, the question where C should be at the end, that will be the answer. This is a trick. C both. Now question is B and D. So which is maximum stable in acid, means B and D. So confusion is in this two. Now if you look at this two reagent, this contains attached one cyano group which has minus I as well as minus R, but since this boron is sp3 hybridized, so minus R can't operate. And here also oxygen has minus I and plus R. Okay. Okay. sp3 here minus I and minus R. I'll explain why I'm writing this. So these are two simple reagents. Now confusion is in this two. So if you remember Luce reaction, I have made separate video about it. So you can find out there what happens in this reaction. Alpha beta unsaturated material or any ketone aldehyde, selectively ketone is reduced because of its excess electron availability on the carbonyl group. Okay. Okay. And in this reaction what happens? Product is, I'll explain. Product is OH and double bond is interact. It is compared that this center is harder because of more positive charge density at this center. That's why hard nucleophile attacks here and reduces. What the reagent used? Cerium 3 chloride, sodium borohydride and methanol. Okay. So from that you can say it is borohydride is hard because sodium borohydrides react methanol and produces sodium BHOME. Some people write it as a 3 and 1, or it is better actually it's a mixture. You can say BH. If this option is given, then accept this. Actual material is BNOME 4 minus N. For example, if it is 1, then 4 minus 1 3, similar. So it's a common formula. It could be 2 like that. And sodium borohydride alone can't reduce, but this reduce means the sodium trimethoxy is more reactive than this. So consequently, the answer we got, which is more reactive. More reactive means less stable in water. Another explanation. Why? Another explanation is, you can see in case of this BHOME, formal negative charge on boron. So what happens? This pushes, that's why hydride can go. So from that point of view, this is more reactive. Okay? So what will be the right answer? First, and about sodium cyanoborohydride. This sodium cyanoborohydride is very less reactive because of the minus I and minus R of this. Actually minus R can't operate, minus actually this cyano withdraws electron density, that's why electron density on hydride reduces, and that's why it is less reactive. Okay, so the answer of this question is maximum stable. I asked stability, please read question carefully. I asked maximum stability, so this is maximum stable, so D must be 1, and previously we have sought out, so the answer will be this. Now this is the explanation how to do it first, because such type of question can save you time. First of all, you have to check what are the borohydride. First, stability in water, this is they asked, first read it properly. So what is the maximum stable? Sodium cyanoborohydride. What is the minimum stable? Lithium borohydride. Then first should be B, second should be C. First should be B. Sorry, I made mistake. It should not be. Answer will be, first should be B, second should be C. So this is the answer. So within a second you can think. And even there could be a confusion whether this is more reactive, less reactive. Some argument may be there. For example, let's remove this. And let's give some other reagents. For example, lithium aluminium hydride. Then the story will completely change. Okay, so I'll explain this thing later. So in this way, you can solve the question within a minute. So try to follow this process of elimination. Process of elimination, what do I mean? Process of elimination, don't need to think about or need to follow about the confusion of this one. You have to know that this is maximum stable, this is minimum stable. So maximum, minimum, this is the answer. You don't need to invest your brain for this confusion. So, okay, this is the explanation and this is formally the end of this video. Some other question could be drawn from here. One, what question? Another question is what I have told. Instead of this, they can give lithium aluminium hydride and ask, then this will be maximum reactive. This will be maximum reactive. Okay? So, in this way, even they can ask that the stability of this reagent, for example, instead of lithium aluminium hydride, or we can give this example E, that is sodium. They can ask this question, this is stability in water. Instead of that, they can ask stability under acidic condition. Same question, but different. Answer will be similar. If it is given this, if this is not given, this sodium cyano, this thing is not given, then the question is this is maximum stable and this is minimum stable. Same answer you got. Now, I believe I should give a little description, although I have described in my video, I will give a little description about this sodium borohydride. Actually, due to the presence of this cyano group, the electron density on this hydride decreases. Consequently, its reactivity decreases and it is very sluggish or less reactive compared to the parent sodium borohydride itself. Understood? This is less reactive. Consequently, what happened? It is more selective also. Where? For example, imine, reductive immunation. Reductive immunation happens, and this imine means what happens? This imine is reduced to amine. Okay. So this reductive immunation happens very efficiently by this sodium cyanoborohydride. Okay. So what happens? And this immunation, this is actually imine which is formed under acidic condition. So it prepared under acidic condition. What does it mean? Under acidic condition, this nitrogen is protonated to give this iminium, and that's why the electron deficiency of this center, that is the electrophilicity of this carbon, electrophilicity of this carbon increases, then only this hydride can attack and reduce it. So in case of this reduction of imine, sodium borohydride is used under acidic condition, and generally we will see the acid is used acetic acid, and the pH, maximum pH, means actually minimum when pH will be low, reaction medium is more acidic. So maximum up to pH 4, this CNBr can survive up to pH 4. If you reduce pH further, it will decompose. Up to pH 4, so all the hydrides cannot stabilize at this condition. Even if you check lithium aluminum hydride or lithium borohydride, they will violently react under this acidic condition. Sodium borohydride will react, but not violently like this too, and this will be stable. So this is the uniqueness of this question. So I suggest you just think about it again and try to follow the strategy what I usually follow. You may think, I am not saying that you have to follow that, but you may think this strategy. It would be helpful to solve such type of question if it comes in your exam. Apparently it looks very easy, but sometimes being overexcited we end up with mistake. So this is the end of this video. I request you to give like, thumbs up if you like my video, and subscribe my channel Chemistry, the Mystery of Molecule, and share this video among your friends, and finally please press the bell icon to get every notification of the new video I upload. So let's see you in my next video.